of came to the forefront, I think the first thing I remember is really the Pacific garbage patch. That was a big news item for a while. It's pops up every once in a while, but it kind of faded a little bit into the background. But microplastics, especially nowadays, is what they're finding with how they affect humans, particularly. Let's see, all right. So, Pacific garbage patch. I'm not sure what that is. A lot of plastics in the waterways. I got some statistics about that later. And unfortunately, yeah, I don't think I want to put that in. I hate to see these pictures, but.
Show one with the bag off of.
Yeah, I know. I hope photographer kind of over there and help. Yeah, if it can breathe, I hope it breathes though. I'm just going to kind of read this. Yeah, this is going to be tough to get in 15 minutes. Plastic, so what is a plastic? Basically, it is something that is malleable. Oh, well, this is the overview. So I'm going to cover what is a plastic, why is it an environmental problem, and what are some solutions. That's kind of overview of the presentation. Plastic is a polymer, which is a type of organic compound. It's long chains of similar molecules. So characteristics, it's malleable. If you know anything about metal, it can be formed into something similar to a metal, soft metal, molded, extruded, pressed, and then retain its shape, the desired end shape. Polymers also can be natural, silkable, DNA, cellulose, protein. They're all forms of a polymer. They have the same kind of a molecular composition. But the ones we talk about primarily in this presentation are synthetic, and they're mostly fossil fuel based. There also are some that are bio-based, but some examples would be nylon, polyethylene, Teflon, epoxy. I think everybody knows this chart, and it shows basically there are hundreds of different types of plastics, but these are the basic ones that most people are aware of, and the most prevalent ones in the environment and are used for consumer goods. Let's see.
The biggest frauds ever perpetrated.
Yeah, this is
3, 4, 5, 6, and 7 are not recycled.
Right. Yeah, and the percentage of recyclability across all those is somewhere between, I've read 4 to 7%, so 5-6% range. Kind of a little higher, like Bill said, for 1 and 2, but the rest pretty much non-existent.
3, 4, 5, and 6, 7, basically 0.
Yeah. And lots of related problems. Let me see, I'm kind of off on some examples. Just to highlight, we all know one that's real famous for the water bottles. You see 2 kind of milk jugs, 3 PVC, that's mostly construction materials, a lot of the plumbing, drain, pipe. So I think those are the 3 big ones. Well, actually, polystyrene. Really 6. 1 and 3 are the most prevalent in the environment. So here are some numbers. Produced per year, 50 kilograms or 110 pounds per person. So for every person on Earth, the equivalent of 110 pounds of plastic is produced per year. That's around 460 million tons per year. That's been doubling every decade since the 70s. And since 1950, we have 9.2 billion metric tons that have been produced. And this is amazing. Half of that has been since 2004. So plastic production really ramped up since the early 2000s. By 2050, the estimated production per year is 1 billion tons. If we continue on the trajectory that we are right now. This is a study by the University of Leeds in the United Kingdom. In 2020, they did the first ever global plastic production or pollution inventory. This was to find out where the plastic's going and what parts of the world it is and why. They found that a lot of it was AI modeling, but they found that around 52 million metric tons enter the environment non-contained every year. That's land application, land and water. Basically, it's from a lack of municipal collection. So 2/3 of that hotspots are the global south, Asia. They found that of that 52 million, 30 million metric tons were burned. That's just by individuals and in landfills, so quite astounding numbers. And here's a map that goes along with that study. You can see India being the number one culprit. I think these are a million, let's see.
Are they generating it or are they taking our trash?
Some of both. This is just what is winding up in the environment. That's kind of the scope of the study. So they're finding that India's got about a little over 9 million metric tons. China was thought to be the main culprit previously, but this study proved it wrong. They're almost 3 million metric tons. Surprisingly, Nigeria came in at number 2, and a lot of it is due to the lack of municipal collection.
It's hard to think the U.S. isn't on there unless they aren't counting what goes in landfills.
Right. Yeah, they're not. It's what winds up not in a contained environment. So it's, whatever gets out in the environment that's really not supposed to be where it's supposed to go. So, that's something I want to look up is how much plastic, like, I think, for instance, they gave an example in this study where the United Kingdom actually uses more plastic than Nigeria, but because their collection system is so tight that Nigeria, they lose 400 bottles worth of plastic per person per day, where in an environment where the United Kingdom was only like 3 bottles worth. It has a lot to do with the systems set up to deal with it. So, history of plastic. Just do this because of interest. So, plastic is not necessarily, like I said earlier, it could be a natural item, and for a long time it's horns, ambers, rubber, tortoiseshell, shellac. Horns used to be heated and molded. Anything that's kind of malleable you can make into a product. And I wish I had a picture. They had a really neat example of a horn lice cone that was really ornate. Interesting. It was about 250 years old. Let's see. So, what's that?
What is Parkinson?
So Parkinson, that was the first, that's kind of like the first modern plastic, let's see, Alexander Parks, I think it was in the United Kingdom. That was cotton fibers dissolved in nitric and sulfuric acid and then mixed with vegetable oil. And it wound up being cellulose nitrate. So, what I read, this was in regard to a lot of ivory and tortoise shells becoming scarce. So they were trying to find alternatives to replace these and make them more affordable for combs, billiard balls, piano keys, I think. So this gentleman produced this product, and again, I need to get some photos. Those are really nice, interesting stuff that was made with this. I'm really surprised. I didn't expect it to look so finished and interesting, but Bakelite, probably everybody's heard of Bakelite, which, you know, that was still around even when I was a kid. I remember some things we had that were Bakelite, and that was by the Belgian Leo Bakelin. And then write a note about how to produce that. So that is the kind of the first synthetic plastic.
You can still get Bakelite.
Yeah.
Jewelry, we were going
Yeah.
Antiques Roadshow.
Well, that's a hard plastic.
Yeah.
Most of the modern ones are, I'll call them soft plastics.
Right. That's where.
These are baking, casserole dish.
Oh, they had dishes.
Bakelite.
Remember the telephone, the radio,
Yeah.
the Bakelite radio? I think my grandma had
I
one.
wonder
of
if
those.
that's from,
So here's where the soft plastic comes in. The boom, the petroleum industry, they kind of teamed up with the chemical folks, and the plastic, the petroleum industry was looking to utilize byproducts, in particular, ethylene gas was a big waste material, and they wanted to try to make money out of that. So, the first instance of a successful product was with the Imperial Chemical Industries Company, 1932. This is a British company. They accidentally created polyethylene. They were trying to create another product, and there was an oxygen leak, and they found the byproduct was soft, resistant to heat, and had some products that they were looking for. And the other thing they're trying to produce, so it was actually by accident that one of the biggest plastics were utilized, polyethylene, was created. DuPont, American company, in the 1930s, further developed plastics. So the plastic product. Overview of the 3 points: environmental pollution, production pollution, and microplastics. So environmental pollution, it does not degrade very well. It takes years, decades, sometimes even thousands of years. It can be mistaken for food by wildlife, cause problems, understandably with that. Clog waterways, sewers, of course it's very unsightly. And it can be rerun for vectors, mosquitoes, because of its waterproof qualities. They can hold water and be a real problem, especially in the third world or the developed world. And leach harmful chemicals, because basically it's made with harmful chemicals as it breaks down. Just some facts to point out: environmental pollution. So the number one, the polyethylene terephthalate. Basically, the number one bottle you see developed in 1973. Today, 500 billion are sold every year worldwide. 5 trillion plastic bags. That is a polyethylene. It's a number 4. Cigarette butts, I can't remember which one that was, but that was cited as a really big contributor to environmental pollution. Yeah, the filters. I read that's like the number 1 by volume. And I probably would have been down since people kind of quit smoking, but anyway, half of all produced plastic is single use. So for the most part, it's just bought and chucked. It becomes either a waste management problem or an environmental problem. So statistically, of the 460 million metric tons produced every year, it's estimated that 350 to 400 million metric tons are disposed of annually. So that's a real small amount that's still in use or recycled. And 1 to 2 billion tons end up in the oceans annually. Production pollution. So it's mostly a byproduct or a product of the fossil fuel industry, all the problems that are related with that. 98% of single-use plastics is from virgin feedstock from fossil fuel products. So, that half of everything produced is single-use. Almost 100% of that is from fossil fuel products. So that just tells you how much of a problem that is in the background. Greenhouse gas emissions for lifestyle predicted 19% of the total greenhouse gas emissions. I think that's for 2040. So that's a big, just the plastic production and transportation, et cetera, is going to be a big part of greenhouse gas emissions if we stay on the same track we're on right now. And of course, the chemical part of the equation has all kinds of problems with air, water, soil pollution, energy consumption to produce it, natural resources to produce it, and of course, toxic waste as a byproduct. And that's from Chemical Alley, Louisiana. So microplastics, those are plastics that are smaller than 5 millimeters, so that's, in my opinion, it's still very visible. If I call them microplastics, this could happen soon here, but it's still a problem. When they break down in the environment, they can become nanoplastics. That's smaller than 100 nanometers, which is basically imperceptible to the naked eye, and those can also migrate through cell structures. And they found that they're winding up in placentas of newborn babies. Of course, most of our organs, arteries. There's not a lot of study that's been done on this as far as the effects on the human body. It's kind of in the beginning stages, but they have found that perhaps it helps with clogging of arteries, endocrine and metabolic disruption, and these are found everywhere: air, water, soil. The primary sources, these are all about 25% each, are synthetic textiles, tires. I always thought about that. What happens to the tire when it wears down and you lose tread? It just doesn't magically disappear. So it winds up somewhere. And city dust, which is a new term for me, that's kind of the erosion of living in the city. It could be people's shoes wearing down, surfaces of buildings. There's all kinds of stuff down this. So solutions are recycling. Not really heralded as a great solution. Currently only 4 to 7%. Bioplastics, those are kind of touted as a solution or help, but again, those present many problems that are similar to synthetic plastics. They don't break down very fast, and most of them need composting assist, as in commercial composting. Chemical breakdown, again, problems with the chemicals used, the process being energy consuming, and incineration, of course, all kinds of problems with that. Toxic gas, CO2 emissions, social justice issues, those are primarily located in underserved communities, and hazardous waste. And it's not really very efficient at producing energy, which is one of the main goals of incineration. So what I've read, mostly people are trying to tout that we need social and political solutions. One is kind of on the consumer, but it also has to do with education and changing consumer habits. Zero waste movement has been gaining popularity. This was interesting, the Plastic Free July. I just heard about this year. There was a lady in Australia that's been working on this for about a decade. What is her name? Rebecca Prince Ruiz. And just recently, the final part of Australia, I can't remember which one it was, was, but they've got a nationwide ban on single-use plastics that's gonna go into effect, so perhaps that's been instrumental in getting that to come about. The other side of it, political solutions. The UN, of course, is taking stances on it. They primarily for educational and purposes, but they had the Global Plastics Treaty in 2022, and they have this environment program that, again, is mostly educational. It's a pretty good website to go to. More effective are local laws, and here in the U.S. we have the EPR laws, which have been passed in 4 states. I think maybe now Minnesota's the 5th recently.
None have been fully implemented yet.
That's true.
That's
Yeah.
TWRRA.
RRA. Yeah, Maine, it passed 2 years ago, and it's going to be fully implemented in 2026, for example. So what Bill said is true, but the basic structure of these laws is to go after the manufacturers. I think primary manufacturers, also the people who utilize plastics, such as stores and dealers, to have them reduce the packaging choices for the products and the amounts used. So choices, more recyclable, better; harder to recycle, worse. But I guess the food is more for the worst choice, and of course trying to reduce the amount used. TWRRA bill, introduced by Sierra Club last year, great bill.
Is that producer buyback?
I'm sorry?
Is that producer buyback?
No, this is packaging.
Just packaging.
It's just packaging.
Right.
And so it's not the buyback things like they have in Europe for electronic products. And it's not, there are a number of ones for paint, oil, and hazardous materials. It's not those. This is just packaging. And the problem came up was that the chair of the committee that we had this ready to pass, we had the votes, the chair didn't bring it up. We could have passed it to the Senate. But he wanted to take on everything for recycling. He wanted a monster bill. Well,
We're just gonna fail probably.
a monster bill is, I mean, this thing here is complicated to sell. A monster bill is, I mean, this is something you gotta, in my opinion, you chip away this one, you chip away that one, and you just go at them one at a time. I'm unaware of anybody, any place that's gone after all of them, because there's so many of them. But we did have Republican co-sponsors in the committee itself. We actually had almost a majority of the committee who were co-sponsors of the bill in the Senate. But right at the last minute, it got, Sutherland didn't have a vote on it, and it went to summer study. And we'll go again. Usually it takes a while to pass this. We came closer than anybody in their wildest imagination would have had. The national people opposed to it didn't even pay attention to us for quite a long time. Then right at the end, when they saw we were making progress, we got a lot more attention. But we're trying to get it to be a governor's bill. Yeah, and that way I'll have a lot better chance of passing.
What's in it for Lee?
I'm sorry.
What's in it for Lee?
He's actually sort of an environmentalist. I mean, Lee's put a lot of money into parks. He does a lot of bad things, but he's interested. He's on his way out. There are a couple of bills we're looking at to see if he will sign on to it as part of his legacy. Because the people in TDEC are in favor and support it. But until the governor makes it one of his bills, they can't say that. But, you know, they're not going around trying to sabotage it or torpedo it. The conflict you have is if you get the sponsor to be a Republican who you don't necessarily trust, they can torpedo the bill by adding all kinds of bad, awful stuff to it. But if you don't have a Republican sponsor, it won't get passed.
Right.
So that's what we're working on now, and I'm just amazed. When we started off, Dan was a real rube, and they all were novices. Now they're so far beyond me. And Gary Cohen has just gone. He's very good. He's a packaging salesman, and he's taken this on. He's worked within the industry, and Dan Firth has really stepped up on this thing. So it's just remarkable.